Good evening to everyone present here. So welcome to our TNSET free online coaching class. So we have seen the last 2 days. So the PDE, the partial differential equations, the unit 3 in the TNSET syllabus. Okay, so today we'll continue on the TNSET unit 3 syllabus, partial differential equation with our resource person, Senthil Nayaki.
Thank
we
you,
can
sir.
start.
Yes, sir. So in the last good evening, everyone. In the last class, we have discussed about the Cauchy problem. So this is one of the important topics in the partial differential equations. So one more problem is that is also very different type of Cauchy problem. The equation is y into dou u by dou x minus x into dou u by dou y equal to 0. So it is looks like Lagrange's equation, but if it is Lagrange's means already I have said this relation has not been given. So u equal to g, this is extra condition. For Lagrange's this condition is no need. So this is a Cauchy problem, that's why they have given the extra condition for u equal to g on gamma. So this is the curve, already we have discussed about this curve. So it has a unique solution. So this point is very important. This in the question itself they have given this Cauchy problem has a unique solution. Okay, so this word is very important. So unique solution means what is the definition? First we have to find out the first ratio. Already I have mentioned it 1. If it is not equal to with condition ratio 2, then we get the unique solution. Suppose the first two conditions are equal and that condition will be equal to the third one, then we get infinite number of solution. And the third point is if the first condition is equal to the second ratio, not a condition, ratio, and these two are not equal to with the third one, then we can say that this is this has no solution. So here in the question itself they have mentioned this Cauchy equation has a unique solution. So the first condition is itself satisfied. So here we have to find out which, for which curve this Cauchy problem has a unique solution. So we have to find out out of these 4 we have to find the correct one, and this is a CSAR net question. So this is coming under part C, CSAR net, this is coming under part C. So there are more number of answers for this question, not a single answer for this question. So we have to find out one by one, because part C has sometimes it has one answer, sometimes it has more than one answer. So already we know about this. So this is a part C question. Okay, so let us discuss one by one. First consider option A, that is gamma equal to the set of all x comma 0. Here x is greater than 0. So x value is in this coordinate, x value is x, but the y coordinate is 0. That means x equal to x and y equal to 0. So for the Kachi problem, what we have done in the last problem, so first we have to write down this equation. From this we can write capital P, Q and R value. With this condition, we can write down the parametric equation for x, y and u. After that we have to convert into the T form. After that we have to find out the derivative, that is dx naught by dt and dy naught by dt and du naught by dt, and we have to find out the ratio. So like that we have solved this type of problem. So here also we are going to do the same thing. For this, first we have considered option 1, that is comma equal to x comma y, set of all x comma 0 where x is such that x is greater than 0. Okay. So the problem is y into ux minus x into uy equal to 0. So from this we can write p equal to y, because this is p and this is q. Therefore q equal to minus x. Then what about r? So here there is there is no right hand side. Therefore r equal to 0. The right hand side term is 0. So the parametric equation we are taking from this curve gamma. So x equal to x. So x naught means initial value, x naught means that is assume this value as t. So x naught equal to t, and y naught value already I have said y naught value is 0. What about u naught? U naught is here u value is g. So u value is g means then u okay. So x naught equal to t and y naught equal to 0. Differentiate this, then dx naught by dt equal to 1 and dy naught by dt equal to 0. So here u is not given. So p of x naught, y naught, u naught. Since p is in terms of y, so we have to substitute this initial value. Then p of x naught, y naught, comma u naught means, so this is p of x comma y comma u. So we have to substitute the instead of y naught, then y naught value is 0. Similarly q value in the at the initial condition, therefore minus x becomes minus x naught. Therefore minus x naught value is t. So this minus x naught becomes minus t. So first we have to find out the first ratio, capital P of x naught, y naught, comma u naught by dx naught by dt. So this value is 0, dx naught by dt is 1, therefore 0 by 1, which is equal to 0. And q by dy naught by dt, q value is minus t and dy naught by dt value is 0, then this value becomes 0. Then we get the first ratio is 0 and the second ratio is minus t by 0. So this 0 is not equal to minus t by 0, isn't it? So if we get the first and the second ratio are not equal, the first and the second ratio are not equal, then we get the unique solution. So in the problem, in the question itself, they have given this equation has unique solution. So if we for this curve, it has a unique solution. So option A, gamma equal to set of all x comma 0 for such that x is greater than 0 is correct. So the first answer is correct. Like second one, B option. What about B option? That is ordered pair of x comma y such that x plus y equal to 1 and x is greater than 0. So here x plus y equal to 1 and x is greater than 1. So here x value is there and y value is there. In the first option y value is 0, but here these two are not equal to 0. Let us check the second option. gamma equal to set of all x comma y such that x plus y equal to 1 and x greater than 0. Already we know that p value and q value. P and q value are common for all options. So p equal to y and q equal to minus 1. This is fixed. This is not vary depending upon gamma. So this is a fixed value. So let us assume that x naught equal to t. Already I have mentioned there is no restriction for assuming the value of t for any for this variable alone. We can assume that x naught equal to t or y naught equal to t. We can assume the t value for any variable, either x naught or y naught. So here in this problem we assumed x naught equal to t. Substitute x naught equal to t in this equation, then x naught, first we have to write in terms of the initial conditions, therefore x naught plus y naught equal to 1, x naught value is t, t plus y naught equal to 1, then y naught is 1 minus t. So already we know that x naught equal to t and y naught equal to 1 minus t. After that differentiate these two relations, then dx naught by dt equal to 1 and dy naught by dt equal to, this is 0. If we differentiate minus t, then we get minus 1. So find out the value of p and q in terms of t. So this is p of x comma y comma u. This is q of x comma y comma u. So first we have to write out in terms of x naught comma y naught comma u naught. So therefore p equal to y naught. Y naught value is 1 minus t. Y naught value is 1 minus t. Similarly, q equal to minus x, that means minus x naught. Minus x naught, therefore x naught value is t, therefore we get minus t. Next we have to find out the first ratio, p by dx naught by dt. So p value is 1 minus t, dx naught by dt is 1. So we get 1 minus t. And q by dy naught by dt, q value is minus t and dy naught by dt is minus t by minus 1, that is t. So from these two ratios we get 1 minus t here plus t. So 1 minus t not equal to plus t, therefore this is the condition for unique solution. So it has unique solution already. This condition has been given in the question itself, therefore second option is also correct. Now let us check the third option. First what is the third option? Gamma equal to x comma y such that x square plus y square equal to 1. So x comma y such that x square plus y square equal to 1. So assume that y equal to t. So here there is no restriction for assuming y equal to t. Instead of y equal to t, you can assume x equal to t also. There is no problem. You get the final answer is the same what we are getting here. So if we assume x equal to t, then what about y? Y equal to 1 minus t square. You can assume like this also. So let x equal to t, then y equal to root of 1 minus t square, or y equal to t, then we get x equal to 1 minus square root of 1 minus t square. So already we know the value of p and q, p equal to y and q equal to minus x. Therefore p equal to y means y value t. Suppose if you assume the first relation means, then you can get the value y equal to root of 1 minus t square. So here I am using this condition. You can check with the first one also. Then q is minus x, x value is minus root of 1 minus t square. So we get the value of x, y, p, q Next we have to find out the value of dx naught by dt, dy naught by dt. Let us consider this as x naught. Similarly, this is p of x naught, comma y naught, comma u naught. Okay. So similarly, q of x naught, comma y naught, comma u naught. So x naught dx naught by dt means differentiate this thing. If you differentiate this thing dx naught by dt, what will we get? So here the power is 1 by 2. So square root of 1 minus t square, power is 1 by 2. So n into the differentiation formula for x power n is n into x power n minus 1. So 1 by 2, 1 minus t square, 1 by 2 minus 1. Then we get minus 1 by 2. After that we have to differentiate the term within this square root. Then this 1, if you differentiate 1 we get 0, and minus t square, if you differentiate minus t square then we get minus 2t. So here 2 get cancelled. So 2 get cancelled, then the remaining term is minus t by, so here minus 1 by 2, so by square root of 1 minus t square. So dx naught by dt is minus t by square root of 1 minus t square. Similarly, dy naught by dt is, here t is, that is the simple term. So dy naught by dt becomes 1. dy naught by dt is 1. So dy naught by dt equal to 1. So second ratio q, so here t get cancelled. So here after you take this term in the numerator, then minus square root of 1 minus t square we get. So here q by dy naught by dt is minus square, q value is minus square root of 1 minus t square, and dy naught by dt is 1, therefore minus square root of 1 minus t square. So the first ratio and the second ratio are equal. So first ratio and the second ratio equal means we have to find out the third ratio. The third ratio is also equal means then we get a infinite number of solutions. So in this question, this problem has a unique solution, therefore option C is not correct. Now let us check option D. Option D is gamma equal to set of all x by x comma y such that y equal to x square for x greater than 0. Assume that x not equal to t. If you substitute x not equal to t, then we get y not equal to t square. Then differentiate, then we get dx naught by dt equal to 1, and dy naught by dt equal to, differentiate with respect to t, then we get 2t. So p value is y naught, that is equal to t square. Similarly, q value is minus x naught, therefore minus t. Next we have to find out the first ratio, p by dx naught by dt. So t square by 1, that is a t square. Similarly, the second ratio q, this is the second ratio, therefore q by dy naught by dt, q value is minus t, dy naught by dt is 2t, so tt get cancelled, we get minus 1 by 2. So what will we get? This first ratio not equal to the second ratio, because this is t square, this is minus 1 by 2, therefore it has unique solution, therefore option D is also correct. So this Cauchy problem has unique solution for these three curves. So the answer is A, B and D. For this alone, P is equal to Q. Okay, so this is not the correct answer. For this problem, this question has three different types of curves, gamma, that is A, B and D. Okay, so now you might be got some idea about Kachi problem. So in the first class, we have discussed about the basics of partial differential equations, that is linear and non-linear partial differential equations. And I have said many times, linear partial differential equation can be solved by Lagrange's, non-linear by Chapit method. Chapit method is the general case. The particular cases for the Chapit methods are there are different types of particular methods are the sub cases, function of p comma q and Clairaut's form, and the function of zpq and the function of f of x comma p equal to function of y comma q. We have discussed we had discussed a few problems in those types. In the second class, we have discussed the solution procedure for the Kachi problem. This Kachi problem is very, very important. In the first problem, we have discussed about the type of solution. So type of solution means uh, with the help of this condition, if this first ratio is not equal to the second ratio, we get the unique solution. If the first two ratios are equal, then that is equal to the third ratio, then it has an infinite number of solutions. If these two, the first and the second ratio are equal, but it is not equal to the third ratio, then it has no solution. So with the help of this result, a simple question will be asked in the set exam. So for this Kachi problem, we have to check this Kachi problem has either exactly one solution or exactly two solutions, infinitely many solutions or no solution. This type of problems may be asked in the set exam, because in the last problem is a little bit difficult. So this type of problems may be asked in net alone. Okay, this is my guess, but you go through this type of problem also. Okay, in this class we are going to discuss uh, the classification of second order PDE, the next topic. Okay, so we have covered linear partial differential equation, that means the solution procedure, and the solution procedure of non-linear partial differential equations. The third one is solution procedure for the Kachi problem. These are all first order PDE, so you have to keep this in your mind. Now, so far we have discussed only the solution procedure of first order partial differential equations. Now we are going to discuss about the second order partial differential equations and the higher order partial differential equations. Higher order, first order, second order means the derivative should be equal to either 1 or 2 or more than 2. If the order of the derivative is 1, then it is first order. The order of the derivative is 2, then it is called second order. If the order of the derivative is more than 2, then it is called as a higher order. So depending upon the derivative order, we can say that is the first order, second order, like that. Let us consider the general second order partial differential equation. It is in the form of AUX plus BUXY plus CUYY. The remaining terms can be written within this function, that is xy. You know that what is x and y. Here x and y are independent variables. X and y are independent variables. So here x and y are independent variables and u is the dependent variable. So x and y are independent variable and u is the dependent variable. these two are independent variables and this u is dependent variable. P and Q, what about P and Q? P is the first order derivative, that is P is ux and Q is uy, first order derivatives. So these type of variables are exist. So here any type of combinations can be exist here. So in general I have written this function of x, y, u, p, q, because we are going to consider only the coefficient of the second order derivatives, that means uxx, uxy and uyy. The coefficient of let us assume that the coefficient of uxx is a, the coefficient of uxy is b, the coefficient of uyy is c. So u is dependent variable, xy independent variables, p and q are like this. Okay, ABC are the coefficient of the second order derivatives and they are all continuous functions and they have partial derivatives in the domain D. Okay, next the important thing in this class is classification. So classification means we have to discuss about the uh, about the type of PDE, that is it may be elliptic or parabolic or hyperbolic. So if it is elliptic means we are finding the value of a, b, c from the given partial second order differential equation. After finding a, b, c value, next we have to find out the discriminant value b square minus 4ac. If b square minus 4ac is less than 0, that is a negative value, then the PDE is elliptic. Suppose b square minus 4ac equal to exactly 0, then the given PDE is a parabolic type. Suppose the discriminant value b square minus 4ac is positive, then the given PDE is hyperbolic. These are all very easy concepts, already we have studied, so you may be recall these things. Next and the example for this type of concept, classify the following PDEs. First question is 2uxx plus 4uxy plus 3uyy equal to 2. So we have to concentrate only on the coefficient of uxx, uxy and uyy. So we have to omit the remaining terms, we don't bother about that. So the coefficient of uxx is 2, that is a value. Similarly, the coefficient of uxy is 4, that is b value. The coefficient of uyy is 3, that is c value. After collecting the values of a, b and c, we have to find out the discriminant b square minus 4ac. So b square means 4 square minus 4, a value is 2 and c value is 3. Therefore 4 square is 16. Then multiply these three numbers, 4 2s are 8, 8 3s are 24. So we get minus 8. Minus 8 means that is the negative value, less than 0. Therefore, if we get the negative value, then the given PDE is elliptic. So the given PDE is elliptic. This is an important topic. You may have a question in this type of concept. Okay, next problem, xy into uxx minus x square minus y square into uxy minus xy into uyy plus py minus qx equal to 2 times of x square minus y square. This is a lengthy question. You should not get fear for seeing this question, because we don't bother about these terms because this is f of a function of x comma y comma u comma p comma q. So we don't bother about these terms. Already I have said. So our aim is we have to collect the coefficient of uxx, that is a. The coefficient of uxy, that is minus x square minus y square. The coefficient of uyy, that is c equal to minus xy. After collecting a, b, c terms, we have to find out the discriminant b square minus 4ac. So b square means here minus of x square minus y square. So we have to square this term, so whole square. Minus 4, a value is xy, c value is minus xy. So minus, if we square the minus term, then it will be positive. Therefore, x square minus y square the whole square. So x square minus y square the whole square plus, because minus into minus is plus 4 xy into xy, so we get x square y square. Expand this by using a minus b the whole square formula, then we get x power 4 plus y power 4 minus 2ab, therefore 2x square y square plus 4x square y square. So adding these two terms, then we subtracting these two terms, we get 4 minus 2 means plus 2. Therefore x power 4 plus y power 4 plus 2x square y square. So we get x square plus y square the whole square. So here we can say that this value is always positive. How can we say? Because if you consider any negative value, for example minus 2 means, after squaring this negative value, what will we get? We get only the positive value, isn't it? So here x square, then this value must be positive. Here y square, this value must be positive. After adding these two values, again we have to square that value also. Then this value must be positive. Then we can say that this is greater than 0, that is positive value. So positive value means what is the case? B square minus 4ac is positive, then the given PDE is hyperbolic. So this PDE is hyperbolic. Okay, let us discuss the third question. Uxx plus 4uxy plus 4uyy equal to 0. So the coefficient of uxx is a, coefficient of uxy is b, and coefficient of uyy is c. You have to collect the a, b, c value in this order. If you consider b is the coefficient of uyy means, then you cannot get the correct answer. So the coefficient of uxx equal to a, the coefficient of uxy equal to b. So you have to collect the coefficient in this order only, otherwise you didn't get the correct answer. So you have to keep this in your mind, coefficient of uxy equal to b and the coefficient of uyy equal to c. Okay, next we have to find out the discriminant value b square minus 4ac. So b square means 4 square, that is 16, minus 4, a value is 1 and c value is 4. So 16 minus 16 equal to 0. So b square minus 4ac is exactly equal to 0. Then what is the result? If b square minus 4ac is equal to 0, then the given PD is parabolic. So here I have taken 3 problems. These 3 problems giving these 3 type of PDEs. That's why I am considering these 3 problems particularly. So first problem is an example for elliptic type of PDE. Second problem is an example for hyperbolic type of PDE. When the variable exists, if it is constant means, then you can easily say that it is negative, positive or 0. If it is a variable means, you have to concentrate in all aspects. You have to think in all aspects. Either it is positive or negative. Is there any possibility for that variable is getting positive value or negative value? So in that all aspects you have to think. So here we can say 200% this value is positive alone, therefore the given PDE is hyperbolic. This is true only for real numbers. Next one is equal to 0. This is an example for parabolic PDE, therefore the given PDE is parabolic. One more type of classification is there. In these three questions, we are collecting the value of A, B and C. But in the next section, we are going to discuss about the classification alone, but they have given, they are not given the value of uxy. If it is uxy is not given, means then you can assume the b value is 0. But let us see what is the problem in the question, then why we have used this method. Let us discuss. See the question. You have uxx plus uyy equal to uzz. So this is a different question, because if it is uxx plus uyy equal to 0 means you can use the previous method, that is very easy. But here extra one term is there, that is uzz, then you cannot use the previous method. So what we have to do, we have to use this second method. So what is the second method? If u is the function of three variables, so you have to note that here the independent variables are three. Independent variables number of independent variables equal to 3. So in this case, number of independent variables is 2. So in this case, independent variables are only 2. So only 2 means we can use this method. Suppose number of independent variables is 3, then we can use this method. So first we have to find out the matrix. How can we find out this matrix? We have to collect the coefficients of the derivative. How can we collect? So see here, Cxx is the coefficient of uxx. Then what about Cxy? Cxy means the coefficient of uxy. Similarly, what about the value of Cxz? The coefficient of uxz. Similarly, we can write down all the entries of this matrix. So Cxx, Cyx means the coefficient of uyx. So Cxy and Cyx, these two are the same. So if you enter this entry, then you can also enter this entry. Okay, let us check the result. If the determinant value is equal to 0, then the equation is parabolic. Okay, so the determinant value is equal to 0, then the given PDE is a parabolic. Suppose the determinant is not equal to 0. The determinant is not equal to 0 means it may be positive or negative. Both the cases are acceptable. So the determinant value may be positive or negative, and we have to check if all the coefficients are positive. This is very important. If all the coefficients are positive, then the given PDE is elliptic. Suppose if the determinant is not equal to 0 and the coefficient are positive and negative, both the sign are present, then we can say that the given PDE is hyperbolic. Okay, are you able to understand? In this second type, in this classification of PDE, number of independent variables are 3, and we have to write down the matrix with the help of the coefficient of the second order derivative. Independent variable is 3, therefore these derivatives are possible. We have to collect the coefficients. After finding the determinant value, if it is equal to 0, then there is no problem. Directly we can say that the given PDE is parabolic. Suppose the determinant value is not equal to 0, then it may be positive or negative, and we have to check one more condition. If the coefficients, this matrix entries are only positive, then the PDE is elliptic. Suppose the entries of the matrix is both positive and negative, then we can say that the given PDE is hyperbolic. Let us see one example for this type of problem. Here uxx plus uyy equal to uz. So here we can say that u is a dependent variable and xyz are independent variables. Therefore, the given equation can be written as uxx plus uyy minus uzz equal to 0. And we have to collect the coefficient. So here x and y z. Similarly here x, y, z. So here x into x, this entry is x into x. So the coefficient of xx is 1. This entry is cxx, so 1. Next, this entry is xy. So coefficient of xy is here there is no term for uxy, so the coefficient is becomes 0. And xz, this entry is the cxz. So here there is no derivative in uxz, therefore this term becomes 0. And this term becomes y into x. So y into x, no term for yx, so 0. And this term is y into y. So y into y means we have the term uyy, so the coefficient is again 1. This is yz, there is no term in uyz. Here zx, there is no term in uzx. Here zy, so here there is no term in uzy. So here uzz, so here there is a term in uzz, the coefficient is minus 1. Now we are collecting all the terms. Next we have to find out the determinant. We filled the entries of the matrix. Next we have to find out the determinant value. So simple answer, simple calculation, we find the answer, that is minus 1. So minus 1 means, already I have mentioned, the determinant value is equal to 0 means the given PD is parabolic. But here this value is not equal to 0. We don't bother about the positive or negative value. So here this is minus 1, therefore not equal to 0. So determinant is not equal to 0 and the coefficients are, the entries of the matrix is either 1 or 0 or minus 1. There are 3 different entries. So here the entries are positive and negative. So the given PD is positive and negative. Positive as well as negative means the given PD is hyperbolic. Therefore, by the result of 3, we can say that the given PD is hyperbolic. So if it is independent variable 2, then you can use the first type. If the independent variables are 3, then you can use second type. Okay. Next, an important one is a characteristic equation. Characteristic equation and characteristic curves. With the continuation of this classification, we are going to discuss about the characteristic equation. This is also very important topic. This is also an important topic, classification. Next we are going to discuss about the characteristic equation and the characteristic curves of second order PDE. Consider a PDE. Already I have given this PDE equation, second order PDE. Here also I am taking the same equation. In the same procedure, collect the coefficient of uxx, uyy. and uxy. Name it as a, b and a, c and b. Okay, then with the help of a, b, c, we have to write down the quadratic equation in lambda. So what about that quadratic equation? A into lambda square plus b into lambda plus c equal to 0. The coefficient of lambda square is the coefficient of uxx. The coefficient of lambda is the coefficient of uxy. The coefficient of lambda power 0, that is constant term, is the coefficient of uyy. So we don't bother about the remaining term. Okay. So we get a quadratic equation. After solving this quadratic equation, what will we get? We get two roots. If it is two roots, means we can write down two characteristic equation in this form. Dy by dx plus the first root equal to 0 and dy by dx plus the second root equal to 0. We get two equations. Let us consider the first case. We have to find out the discriminant value b square minus 4ac. If it is strictly greater than 0, then the given PDE is hyperbolic. So for the solution of this quadratic equation, we know the formula. What is the formula? Minus b plus or minus square root of b square minus 4ac by 2a. This is the basic formula for solving the quadratic equation. So if b square minus 4ac is greater than 0, then the square root value becomes positive. So this term becomes positive, means we get two distinct real roots. Then we can get two characteristic equation in this form. After solving these two characteristic equations, we get two distinct family of characteristic equation. Okay. Next, second case. If b square minus 4ac equal to 0 means, then this term becomes 0. Then there is no plus or minus term. So only one root minus b by 2a we will get. So minus b by a is a single root. Therefore, if b square minus 4ac, the given PDE is hyperbolic. Sorry, I am very sorry. The given PDE is parabolic. Therefore, equation 2 has this quadratic equation. This quadratic equation has single real root. So single root means we get only one characteristic equation, dy by dx plus lambda equal to 0. Solving this equation, we get one family of characteristic, because only one root is there, therefore only one equation we get. After solving, we get one family of characteristic. But in the case of hyperbolic, there are two roots are possible, therefore we get two distinct family of distinct, because these two roots are distinct, therefore we get two distinct family of characteristics. Okay, so here we are discussing hyperbolic in case 1 and parabolic in case 2. Then what about case 3? Yes, case 3 is elliptic. Elliptic means b square minus 4ac less than 0. Okay, so b square minus 4ac is less than 0 means think about this square root value. What will we get? Within the square root we get negative value. Then what about the value? The square root of negative value becomes, yes, complex value. I mean imaginary root value. So in the third case, equation 2 has complex roots. Okay, So there is no real characteristic. We get two family of complex characteristics. We get two family of complex characteristics. Okay. Now we are going to discuss about the characteristic equation and the characteristic curve. In the next class, we are discussing a problem related with the canonical form. The canonical form is very important and it is very difficult also. It consumes more time for solving this problem, but that is very important. So for in the subject PDE, canonical form is yeah, an important topic. So we will discuss about the canonical form in the next class. Now we are going to discuss some example for this characteristic equation and characteristic curve. Let us consider a PDE, that is a second order PDE, 4uxx plus 5uxy plus uyy plus ux plus uy equal to 2. You don't bother about these three terms. So you have to concentrate only on the second order, the coefficient of second order derivatives. Okay, already I have said so many times the coefficient of uxxxa and the coefficient of uyxy is b, and the coefficient of uyy is c. Okay, then a, b, c value we are getting from the given partial differential equation. Next we have to find out b square minus 4ac value. B square minus 4ac means b value is 5, therefore 5 square minus 4, a value is 4, c value is 1, therefore 5 square is 25, 4 4s are 16, 25 minus 16 is 9. So this is greater than 0, therefore the given PD is hyperbolic. So hyperbolic means the square root value becomes positive. B square minus 4ac is positive. So we get two distinct real roots. Okay. If you carefully follow my lecture, then you can easily understand. You can easily understand and you can easily solve this type of problem in the set exam. So quadratic equation in lambda becomes a lambda square plus b lambda plus c equal to 0. Then a value is 4, therefore 4 lambda square, b value is 5 plus 5 lambda, c value is 1, then 1. So 4 lambda square plus 5 lambda plus 1 equal to 0. Solve this equation multiplying these two. So 4 into 1 is 4. You have to get if you considering two roots, then the multiplication of those two roots is 4 and the addition of two roots is 5. So the answer is 1 and 4 alone. So if you multiply these two, then 1 into 4 is 4. 1 plus 4 is 5. So the roots, sorry, not the roots, then the product is 1 into 4, sorry, 1 and 4. So we can split this 5 lambda as 4 lambda plus 1 lambda with the help of this thing. So 4 lambda plus 1 into lambda. So we can split this 5 lambda like this. So 4 lambda square plus 4 lambda plus 1. So from the first two terms we can take 4 lambda as a common term. So remaining we get lambda plus 1. In this term if we take 1, then lambda plus 1. In these two terms we get a lambda plus 1 as a common term. So the remaining term becomes 4 lambda plus 1. Therefore the roots are minus 1 by 4 and minus 1. So we get two real roots. Then the characteristic equation is dy by dx plus lambda 1. Therefore minus 1 by 4, because the first root is minus 1 by 4. and the second characteristic equation is dy by dx plus lambda 2, that is minus 1. Okay, then dy by dx equal to 1 by 4, then dy by dx equal to 1. Cross multiplying, after integrating, we get 4y equal to x plus the integrating constant c1. After integrating the second characteristic equation, we get y equal to x plus c2. Therefore, the characteristic curves are 4y minus x equal to c1, y minus x equal to c2. You can simply find out the characteristic equation, and solving those two characteristic equations, we get characteristic curves. This is an important topic. You can get um, full marks from this topic, that is classification, either two independent variable or three independent variables, and the characteristic equation and the characteristic curves. Okay, now we are going to discuss about the solution procedure for higher order partial differential equation. That is very important and very easy also. Already you have discussed about ordinary differential equation. You may aware of the solution procedure for ordinary differential equations. Then you can easily understand the higher solution procedure of higher order partial differential equations. So in this type 1, that is exponential case, it is in the form of e power ax plus by. So consider a partial differential, a second order partial differential equation. Here z is a dependent variable and x and y are independent variables. Then dou square z by dou x square minus 5 into dou square z by dou x dou y plus 6 into dou square z by dou y square equal to e power x plus y. The right hand side is in the exponential form, therefore it is type 1. So type 1 means we have to replace d by a and d dash by b. What about d and d dash? D is dou by dou x, the partial derivative with respect to x. What about d dash? D dash means the partial derivative with respect to y. It is a notation, not a derivative. Please do not uh, misunderstand. This is the derivative of d. This is d dash. It is also a differential operator with the this is equal to the partial differentiation with respect to y. This is the partial differentiation with respect to x. Then what about d square? D square means dou square by dou x square. So this term dou square by dou x square can be written as d square. Then what about dou square by dou x dou y? This is d and d into d dash, because dou by dou x is d and one more dou by dou y is d dash, therefore d dash. Similarly, dou square by dou y square, this is d dash square. First we have to write down the given PDE into d and d dash format. So d square minus 5 into, this is coefficient, minus 5 into d dash plus 6 into d dash square equal to into z, because z is a dependent variable. We have to take this term as a common one, so into z equal to e power x plus y. Next we have to find out the auxiliary equation. How can we write the auxiliary equation? Means replace d by m. Already we have done this for done in ODE, the same thing, but extra one thing is we have to replace d dash by 1. So d by m and d dash by 1. So d square means m square minus 5 into m into 1. plus 6 into d dash square. We have to write 6 into 1 square. 1 square is 1. So 6 into 1 square is 6. So the auxiliary equation is m square minus 5m plus 6 equal to 0. So we have to find out the roots satisfying these two. If you multiply, you get 6. If you multiply, you have to get minus 5. So if you add, then you have to get minus 5. Then minus 2 and minus 3, these two numbers satisfying these two conditions, then m minus 2, m minus 3 equal to 0, then the roots are 2 comma 3. Then we have to write out the complementary function. Complementary function equal to, there are two roots, so we have to use two arbitrary functions. So the first one is pi 1, the second one is pi 2. So the form is pi 1 of y plus 2x plus pi 2 of y plus 3x. So this 2 has come here and this 3 has come here. So pi 1 of y plus 2x plus pi 2 of y plus 3x. Suppose 5 and 6 are roots, means we can write pi 1 of y plus 5x plus pi 2 of y plus 6x. Okay, this is an example, and we have to find out the particular integral. So particular integral means 1 by d square minus 5d d dash plus 6d dash square e power x plus y. So here already I have mentioned, if it is the right hand side, means we have to replace this a by d, sorry, d by a and d dash by b. So here a is 1 because the coefficient of x is 1, and b is 1 because the coefficient of y is 1. So replace d by 1 and d dash by 1. So what will we get? 1 square minus 5 into 1 into 1 plus 6 into d dash square, then 1 square into e power x plus y. So after simplifying, 1 minus 5 plus 6. So we get 6 plus 1 is 7. 7 minus 5 is 2. So 1 by 2 e power x plus y. So this is particular integral value. Therefore the general solution is, why we are saying this is a general solution? Very first class we have discussed three different type of solution: complete solution, singular solution, and general solution. Why we call it as a general solution? Because the arbitrary functions are present in this solution. If at least one arbitrary function is there, then the solution is called general solution. Okay, so here there are two arbitrary functions are there, therefore this is called a general solution. So is it equal to pi 1 of y plus 2x, that is complementary function plus particular integral. Complementary function is this one and a particular integral is this one. So we have to combine these two, we get the general solution of the given PDE. Similarly, the second problem, d square minus 4d d dash plus 4d dash square into z equal to e power 2x minus y. So the right hand side is exponential term. So we get a value as 2, a value is 2 and b value is minus 1. First we have to find out the complementary function. So for the complementary function, we have to replace d by m and d dash by 1. So we get m square minus 4m plus 4 equal to 0. After factorizing this equation, we get the roots m equal to 2 comma 2. Then CF is, so here we get equal roots. Equal roots means the complementary function becomes pi 1 of y plus 2x, x into plus x into pi 2 of y plus 2x. Okay, x into pi 2 of y plus 2x. This is the complementary function. If it is 3 roots means 2 comma 2 comma 2 means, then the complementary function becomes pi 1 of y plus 2x plus x into pi 2 of y plus 2x plus x square into pi 3 of y plus 2x. Like that we can write if it is equal roots means. And then pi is 1 by d square minus 4d d dash plus 4d dash square into e power 2x minus y. Therefore a value is 2, b value is minus 1, so d is replaced by 2 and d dash is replaced by minus 1. Then we get 1 by 2 square minus 4 into 2 d dash minus 1, then 4 minus 1 the whole square. After simplifying we get 2 square is 4, 4 into 2 is 8, 8 into minus 1 minus 8, minus into minus plus 8. Minus 1 the whole square is plus 1, plus 1 into 4 is 4. So we get a 16, 1 by 16 e power 2x minus y. So therefore the general solution is CF plus PI. CF is this one, pi 1 of y plus 2x plus x into pi 2 of y plus 2x plus PI is 1 by 16 into e power 2x minus y. Okay, this is first type. Second type is polynomial. So if it is a polynomial means we have to use any one of these 4 formulas. 1 minus x whole power minus 1, the equal to 1 plus x square, etc. The second formula is 1 plus x whole power minus 1, then we get 1 minus x. The same formula, the same right hand side, but alternative plus and minus will come in the second formula. Third one is, in the same first formula we have to write 1 2 3 4 like this. Okay, fourth formula, if it is plus means here plus minus, here plus here minus means the right hand side should come with the alternate sign. So here also in the second and fourth formula is almost same. Right hand side alternatively we get plus and minus sign. Similarly in the fourth problem alternately we get plus and minus sign. But in the first and the third formula, in both the place has minus sign, then the right hand side terms are all positive. If it is power minus 2 means, that is 2 means, then the right hand side is 1 2 3 4. What about the next one? 5x power 4. What about the next one? 6x power 5, like that. Similarly the fourth one. So we have to use any one of these 4 formulas. CF is common for all type. PI will vary. So for finding CF, we have to replace d by m and d dash by 1. Then m square minus 7m plus 6 equal to 0. After finding the roots, the CF can be written as one comma 6. Therefore the solution CF is pi 1 of y plus 1x no need to write 1x. The solution is pi 1 of y plus x plus pi 2 of y plus 6x and pi. For finding pi, 1 by d square minus 7d d dash plus 6 d dash square into xy. So first we have to convert this denominator as either 1 plus or 1 minus form. Already I have said we have to use any one of this formula. So we have to convert this denominator as either 1 plus or 1 minus. For this purpose we have to take out d square as a common term. Okay, firstly we have to take out d square. Then this term becomes 1. Here there is no d square, so here also there is no d square, so we have to divide these two terms by d square. So what will we get? 1 by d square into 1 minus, take minus sign is also as a common term. So we get this term is plus and this term becomes minus. So 7d d dash minus 6d dash square by d square into xy. Next 1 by d square 1 minus divide these two terms, then d get cancelled, the 7d dash by d. Here 6d dash square by d square. If you take this term into numerator, then the power will be minus 1 into xy. So you have to use this first formula, 1 minus x whole power minus 1, then 1 plus x square we get. So we have to differentiate this term. So d dash of xy is x, because d dash means dou by dou y. So differentiate once with respect to y, then this one y is y becomes 1 and x is a constant. So x into 1 is x. If you differentiate this term again with respect to y, that is d dash square, then this becomes 0 because there is no y term. Therefore the constant term, if you differentiate the constant term, then we will get a 0. So 1 minus 7d by d dash, so 7d dash by d minus 6d dash square by d square whole power minus 1 into xy. So finally we get only in this expansion only two terms, first two terms are nf. So 1 plus 7d dash by d minus 6d dash square by d square. The full term becomes x. So 1 plus x is enough. If you go further, if you choose x square means, then 7d by d minus 6d dash square by d square becomes the whole square, means you have to expand a minus b whole square, then d dash square 0, d dash power 4 0, d dash cube is also 0. Then there is no need for going the third term, only two terms are enough. Therefore 1, this is the first term, x, that is this term 7d dash by d minus 6d dash square by d square. These first two terms are enough. This is x1 and this is x. So this these two terms are enough. So after expanding further, we will get only 0 values, so no need to expand further. These two terms are enough into xy. So 1 into xy is xy, 7 d dash by d into xy minus 6 d dash square by d square into xy. So xy, if you differentiate one time with respect to y, we get 7 by d into x. D dash square 2 time means that term becomes 0. So 1 by d square into xy plus 7d into x. So we have to integrate with respect to x. Before integrating, multiply this 1 by d square in each and every term. So 1 by d square of xy, 7 by d cube of x. So you have to integrate 2 times with respect to x. Here you have to integrate 3 times with respect to x. If you integrate first time means x becomes x square by 2. Here x square by 2. If you integrate the second time, then we get x cube by 3. Already we have 2. So 2 into 3 6, up x cube by 6. Similarly, if you differentiate third time, then we get x power 4 by 4 into 6. Therefore x power 4 by 24. So we get y x cube by 6 plus 7 x power 4 by 24. This is Pi. The general solution is Cf plus Pi. Therefore Cf is pi 1 of y plus x plus pi 2 of y plus 6x. This is Cf, and Pi is x cube y by 6 plus 7 x power 4 by 24. This is the general solution. Similarly, we can solve this problem also. Polynomial is a little bit difficult when compared to other types. Okay, so we will stop the class with this problem, After discussing this problem, we will wind up the class. The remaining we will see in the next class. Okay. So first we have to find out the auxiliary equation. Then m square plus 3m plus 2 equal to 0. After finding the roots, CF can be written as the roots are minus 1, minus 2. M equal to minus 1 and minus 2. Therefore, the roots are, CF is pi 1 of y minus x plus pi 2 of y minus 2x. Pi 1 by d square plus 3 dd dash plus 2 d dash square into x plus y. So take d square as a common term in order to change the denominator as either 1 plus or 1 minus. So d square means 1 plus 3 dd dash plus 2 d dash square by d square, dd get cancelled. So we get 1 by d square into 1 plus 3 d dash by d plus 2 d dash square by d square into x plus y. So we have to expand this. The formula for this is 1 minus x plus x square minus x cube, like that. So here also no need to go further, only first two terms are enough. So 1, here minus sign is there because one term is plus, one term is minus, so alternately plus minus will come. So minus 3 by d, minus 3 d dash by d into x plus y, and then minus 2 d dash by d square into x plus y. So 1 into x plus y. So 1 into x plus y means x plus y minus 3 by d, d dash of this term becomes 1. So 3 by d into 1. D dash square of this term becomes 0. So the third term becomes 0. So here minus sign. Okay. Then 1 by d square into x plus y minus 3 by d into 1. So multiply 1 by d square within this bracket, then we get 1 by d square of x plus y minus 3 by d cube of x. So first term you have to integrate with respect to x 2 times, then x square by 2 and x cube by 6. This is the first term. Similarly, here 1 is there, y is a constant with respect to x. So 1, if you integrate 1, then we get, so here no, not x, only 1. This is not x, only 1 is there. Okay. So if you integrate 2 times means, then first time integration we get x, second time x square by 2. Similarly here we have to integrate 3 times, then first time the term become x, second time x square by 2, third time x cube by 3, 3 into 2 is 6. So we get 3x cube by 6. So this is Pi. So the general solution is z equal to pi 1 of y minus x plus pi 2 of y minus 2x plus x cube by 6 plus x square y by 2 minus 3x cube by 6. Okay. So type 3 we will discuss in the next class. Thank you.
Thank you, ma'am.
Thank you, sir.
Thank you.